All right, let's talk about logarithms. I want to specifically talk about the common log and the natural log, but just a quick review real fast is something like the log base 2 of 8 has an answer of 3. And the reason it's 3 is because 2 to the third power equals 8. The base of a logarithm is giving you the base of an exponential expression. The input, or the value here, is what an exponential expression would output, and then the resulting answer is an exponent. And a really good way to remember logarithms is that logarithms are exponents. They represent exponents. Everything with logarithms, all kind of the weird properties and rules, are because logarithms are exponents. And just again, real fast for some review. So if I had something like an easy one would be like log base 5 of 25. That's 2, right? Because 5 raised to the second power equals 25. Some not so simple things would be things like, let's see, log base 4 of 2. This one is a 1/2. Because 4 to the 1/2 is the same thing as the square root of 4, if you remember rational exponents, and that would give you a 2. So 4 to the 1/2 is 2, therefore log base 4 of 2 is 1/2. Another kind of not so straightforward one, somewhat related to our first example, is if I did like log base 2 of 1/8, that answer is -3. And again, to show the work there is because 2 to the -3rd equals 1/8. If you remember, negative exponents have to do with this reciprocal, right? So we take 2 to the 3rd, which is 8, but the negative makes it a 1/8. Okay, so there is the basis of logarithms right there. I want to get into the more interesting or important conversation right now, which is the common log, and the natural log. But before I do that, I want to just summarize a main definition or property. It's a property of logarithms, but I consider it kind of the definition of logarithms also, which is the log base b of b to the r equals r. And I'll rewrite my first example up there in this form. What that means is if you're asked a question like the log base 2 of 2 to the 3rd, I sometimes joke that this is the Grant's white horse question. My dad used to always joke about like, hey, what color is Grant's white horse? And the joke, I guess, as a dad joke goes, is that the question has the answer in it. You're being asked what color is Grant's white horse. The horse is white. In this case, the question being asked here is, hey, what exponent do I raise 2 to get to 2 to the 3rd? And the answer is, of course, the answer is in the question. There's the exponent right there. So remember that. That's an important concept. Now, to the common log and natural log. First and foremost, our calculators generally have two logarithms. One looks like this, just log. That is the log base 10. So, for instance, if we put a value like 100, if we in our calculator type log of 100, what we're asking our calculator is the log base 10. So 10 is the number that we're using as the exponential base. And that would obviously give us the answer 2. So this one is called the common log. That's the first logarithm we have in our calculators. And then the other one is the natural log. This one is also extremely common. This is the log base e. Often we see logarithms, people experience logarithms before they really understand or know much about e. You've seen irrational transcendental numbers like this before. For instance, you know pi. So just over here on the side, we've all seen this from earlier in our mathematics, is that pi is 3.1415, yada yada. It's an irrational number that goes on forever. The decimal part does. E is very similar. E is 2.0 718, and that goes on forever. This is an important number in exponential expressions. If you ever get into like compound interest and continuously compounding, you see E a lot. I won't go into that now, but just know that E is a number, it's important, and well, you're going to see it in many problems because of the use of natural log. And the point I want to just say here is that natural log, for instance, if we asked a question of the natural log of E to the fifth, that equals the log base E of E to the fifth. And now the thing to point out here is just that if we we take the natural log of an expression that involves E, it works really nicely because of this property up here above. This answer is just 5. Again, because we're using the logarithm that's the same base as this exponential expression right here, and it works out beautifully. So people often ask, the question is like, hey, which do I use, log or natural log? Sometimes in examples I'll see log used, and sometimes I see natural log used. It really doesn't matter. Just for instance, if you were to compute something with the change of base formula, and let's say you're being asked to compute the log base 5 of 30. If you had to compute that, the change of base using the common logarithm looks like this. It's the log base 10 of 30 divided by the log base 10 of 5. Another option actually would have been to use the natural logarithm, the natural log of 30 divided by the natural log of 5. The key is it doesn't matter which one of these you use, they'll give you the same result, which is about 2.11, which is an approximated version of those. And you can try it in your calculator. It really doesn't matter if you use logarithm or natural logarithm when you compute this. All right, now let's talk about solving an exponential equation. First and foremost, in this expression right here, the base of the exponential part, exponential factor, excuse me, is E right here. This means it will be easiest to use the natural logarithm. Here's how I would solve this. The first thing I would do is I'm going to divide both sides of this equation by 19. I do that to cancel out this 19 here, and then I'll just leave that right side as 17 divided by 19. So what I get is e to the x equals 17/19. Now I'm trying to solve for x. What can I do next? What I'm going to do is I'm going to apply the natural logarithm to both sides of this equation. And again, it's because of that base e. So let me just take a second here. I'm going to apply the natural log to both sides of this equation. The reason for using the natural log in this case is because, again, now on the left-hand side, this is the log-based e of e to the x. The result of that, if you think back to that beginning description of the definition or the property of logarithms, is this is just x. Because it outputs, this is log base e of e to the x. The output is just that exponent right there. That only works because I'm using the natural log. I get x equals the natural log of 17/19, which I've approximated here on my calculator, and I get negative 0.111, I guess, right there. So in the bigger question about when do I use a log base 10 or the common log, or when do I use the natural log, it doesn't really matter. I actually could have used the log base 10 here. I won't show that. It would have been a lot messier. But in this case, if my base is either e or 10, the decision has basically been made for me. If my base is not e or 10, then it really won't matter which one I use.